We are in the class of the course on Information Communication and Society under Discipline Master of Library and Information Science. We shall discuss Unit 2 Types and Sources of Data in Module Information Life Cycle of this course. Data is the backbone of modern decision making, research and innovation. Whether in business, academia, governance or personal pursuits, understanding and utilizing data effectively is essential for achieving goals and generating insights. In this class, we are going to discuss different categories of data as dealt in different fields of study and practices, and also discuss sources of data. It begins with exploring the role of data in generating knowledge, role of core data in dealing with data, types of data, highlighting variations across fields like sciences, social sciences, industries and businesses, etc. Then we cover different sources of data, distinguishing between primary and secondary sources, internal and external sources, and also cover what is big and open data. Now, what is data and what is its role in knowledge creation? During research and developmental activities, a researcher collects data from the subject in his research domain through the variables he or she has taken in light of his research objectives. So, the values collected through these variables lie in the base level of the research as shown in this triangle or pyramid. These values are nothing but the data. Values are the actual units of measurements of the variables. These are data in their most concrete form. To collect these values, a researcher set variables. Variables thus are the components of the indicators which can be measured. And in research, an indicator is an observable and measurable entity that serves to define a concept in a practical way. It also yields data to provide a summary overview of a specific concept. Say for example, an intelligence test is used as an indication of intelligence. So, an indicator provides or yields values that can be used to measure the existence of the concepts. Thus, data are the primary ingredients in research and developmental activities and in other practices and activities also, such as in decision making. But as we are emphasizing on research and developmental activities in this class, thus the collected data are organized and analyzed to build new concepts. Then the concepts founded and created over the collected values or data act as the building blocks of the theory, and theories are representing knowledge and make claims that the world and how it works. Thus, theories are representing knowledge and make claims about the world and also how it works. Thus, we can understand the significance of data in research and developmental activities and is knowledge creation, because above all, data is the foundation for this process of knowledge creation through research and developmental activities. Now we move on to the discussion on types of data, because it is very crucial for the researchers and practitioners to recognize what type of data they require for their research and developmental activities and other practices in different sectors of knowledge. Now, what are the types of data? Data have been broadly classified into two categories according to their sources, as primary data and secondary data. Primary data is the values or facts collected directly by a researcher or organization for a specific research project or for any specific decision making activity. While secondary data is information that has already been collected by someone else. Secondary data in research are derived from primary data. Apart from this basic division, data can be categorized in several ways based on their characteristics, nature, structure, availability, accessibility, etc. For instance, it can be categorized as structured or semi-structured or unstructured based on how well organized and accessible the data is for processing. Thus, each categorization helps determine the most suitable method for storage, analysis and its application for the purpose of research and developmental activities or for decision making. Now, before going into the different categories of data, we shall discuss briefly the role of core data in dealing with data, because core data gives directives or principles in dealing with data, particularly in the field of science. Core data, the Committee on Data of the International Science Council, helps advance International Science Council's vision and mission of advancing science as a global public good. CODATA was previously known as Committee on Data for Science and Technology. The mission of CODATA is to strengthen international science for the benefit of society by promoting improved scientific and technical data management and use. Its general objectives are the improvement of the quality and accessibility of data as well as the methods by which data are acquired, managed and analyzed. CODATA is concerned with data in the fields of physical, biological, geological and astronomical sciences or in any other fields where data are generated. It emphasizes particularly to data management problems common to different scientific principles. The CODATA strategic plan identifies three priority areas in dealing with data. These are promoting principles, policies and practices for open data and open science. Here it is to be mentioned that science as an open enterprise was reported by Royal Society in 2012. Next, CODATA strategic plan identified advancing the frontiers of data science and also identifies the priority area of building capacity for open science by improving data skills and the functions of national science system needs to support open data. CODATA works also to advance the interoperability and the usability of such data and supports that research data should be intelligently open, or FAIR signifies findable, accessible, interoperable and reusable data. Now we discuss about different categories of data as dealt in different disciplines, particularly in respect to R&D activities. We discuss types of data in sciences, social sciences and humanities and many other fields and practices. Now, types of data in sciences. The core data task group on accessibility and dissemination of data recognized in 1975 the need for categorizing data while working on its report on the problems of accessibility of data. The task group evolved a scheme according to which the different categories of scientific data are formed, such as data with reference to time factor, data with reference to location factor, data with reference to mode of generation, data with reference to the nature of quantitative values, data with reference to terms of expression and to mode of presentation. Now we discuss in details. Data with reference to time factors may be time independent data or time dependent data. Time independent data refers to the data which can be measured repeatedly, as for example data in geosciences and astronomy such as geological structures, rocks, fixed stars, etc. Time dependent data can be measured only once, such as certain geophysical or cosmological phenomena like volcanic eruptions and solar flares. Likewise, data pertaining to rare fossils are also time dependent data. Next, data with reference to location factor. These refer to the location factor can be considered as dependent on the location of objects measured, such as data in earth sciences and astronomy normally belong to this category, and location independent data. These are independent of location of objects measured, as for example data on pure physics or chemistry. Data with reference to mode of generation. There are three types of data under this category. These are primary data, derived data and theoretical or predicted data. Data are primary when obtained by experiment or observation designed for the measurement. As for example, values of velocity derived by measuring length and time. Derived data may be obtained by combining several primary data with the aid of theoretical model. Theoretical data derived by theoretical calculations. Basic data such as fundamental constants are used in theoretical conclusions. For example, data concerning solar eclipses are predicted with the use of celestial mechanics. These are theoretical or predicted data. Data with reference to the nature of quantitative values, and they are categorized into two classes: determinable data and stochastic data. Data on a quantity which can be assumed to take a definite value under a given condition are known as determinable data. Time dependent data are usually determinable data if the given condition is understood to include the specification of time. As for example, measurement of diffusion of a dye in a solvent over time to calculate diffusion coefficients. Stochastic data. Stochastic means the property of being well described by a random probability distribution. Data relating to a quantity which take fluctuating values from one sample to another, from one measurement to another under a given condition are referred to as stochastic data. As for example, the growth of a bacterial population or the movement of a gas molecule. In geosciences, most data are stochastic, such as frequency, intensity and duration of volcanic eruptions. Next, data with reference to terms of expression. The categorization in this case yields three classes of data: quantitative data, semi-quantitative data and qualitative data. Quantitative data are measures of quantities expressed in terms of well-defined units, changing the magnitude of a quality to a numerical value. Most data in physical sciences are quantitative data. Semi-quantitative data consist of affirmative or negative answers to posed questions concerning different characteristics of objects involved. As for example, in biology, classification of organisms is based upon a set of yes or no responses to questions concerning morphological, biochemical and other characteristics of species. Qualitative data are expressed in terms of definitive statements. Qualitative data in this sense are almost equivalent to established knowledge. Data with reference to mode of presentation. These are categorized as numerical, graphic and symbolic data. Numerical data are presented in numerical values. Most quantitative data fall in this category. Graphic data are presented in graphic form or as models. In some cases, graphs are constructed for the sake of helping user grasp a mass of data by visual perception. Charts and maps also belong to this category. Symbolic data are presented in symbolic form, as for example, symbolic presentation of weather data. So, these 6 basic types of scientific data based on the nature of data are divided into 15 different classes of data. Next, we discuss types of data in social sciences. Data in social sciences are organized in different types so that their nature can be easily understood. We discuss the types as normally observed in social sciences, such as data with reference to scale of measurement, with reference to continuity, with reference to number of characteristics, with reference to time, and data with reference to origin, data with reference to characteristic. Now, data with reference to scale of measurement. Based on the scale of measurement, data can be categorized as nominal data, ordinal data, interval data and ratio data. These are commonly referred to as levels of measurement. Nominal data is a type of qualitative data, that is the most simplest form of data in reference to scale of measurement. It is used for assigning the numbers as the identification of individual unit. For example, the number of jersey of a players in a cricket team may be considered as nominal data. The numbers are assigned to identify the players, but they do not show at least any order of the players in the team. Next, we have ordinal data. It indicates the ordered or graded relationship among the numbers assigned to the observation mates. Here, the order of the values are observed. The numbers connote ranks of different categories having relationship in a definite order. For example, to study the responsiveness of library staff, a researcher may assign 1 to indicate poor, 2 to indicate average, 3 to indicate good and 4 to indicate excellent. The numbers 1, 2, 3 and 4 in this case a set of ordinal data which indicate that 4 is better than 3 and in turn is better than 2 and so on. The ordinal data show the direction of the difference and not the exact amount of difference. Interval data are ordered categories of data and the differences between various categories are the of equal measurement. For example, we can measure the IQ or intelligence quotient of a group of children. After assigning numerical value to the intelligent quotient or IQ of each child, the data can be grouped with interval of 10 like 0 to 10, 10 to 20, 20 to 30 and so on. In this case, 0 does not mean the absence of intelligence and children with IQ 20 are not doubly intelligent than children with IQ 10. Ratio data are the quantitative measure of a variable in terms of magnitude. These are the types of quantitative data that are measured on a continuous scale with equal distances between adjacent values. It has a true and absolute 0 point. In ratio data, we can say one thing is twice or thrice of another, as for example, measurements involving distance, weight, price, etc. So, these are the 4 types of data with reference to scale of measurement. Next, we discuss data with reference to continuity, which may be categorized as continuous data and discrete data. Continuous data are an infinite set of possible values. Between a specific range, there are infinite possible values. For example, height of individual is not restricted to values like 150 centimeter and after that 156 centimeter. It can be 155.59 centimeter or 155.99 centimeter. So this is the example of continuous value. But in case of discrete value or discrete data are finite or potentially countable set of values. For example, the number of members in a library cannot be 1.5 or 155.59. It can be 2575 or 155 and 156. Similarly, the number of citizens in a country or the number of vehicles registered are the examples of discrete data. Next, data with reference to the number of characteristics. Data can be categorized on the basis of number of variables considered, such as univariate data, bivariate data and multivariate data. Univariate data are obtained when one characteristic is used for observation, as for example, performance of students in a given class. Bivariate data results when instead of one, two characteristics are measured simultaneously, as for example, height or weight of 10th class students. Multivariate data consists of observations on three or more characteristics such as family size, income and savings in a metropolitan city in India. Next, we consider data with reference to time. There are two types of data under this category. These are time series data and cross-sectional data. Data recorded in a chronological order across time are referred to as time series data. It takes different values at different times. As for example, the number of books added to a library in different years, monthly production of steel in a plant, yearly intake of students in a university. Cross-sectional data. This refers to data for the same unit or for different units at a point of time. For example, data across sections of people, region or segments of the society. Data with reference to characteristic. Data can be categorized on the basis of characteristics as quantitative data and qualitative data. When characteristic of observation is quantified, we get quantitative data. Quantitative data results from the measurement of the magnitude of the characteristics used. For example, age of a person, price of a commodity, income of a family, number of books issued in a library. Qualitative data. When the characteristic of observation in a quality or attribute, we get qualitative data. For example, intelligence of a student or gender of a person. Other than these, data in humanities and the arts. We have categorized data in sciences and social sciences, and in humanities, data can be seen or observed as textual data, visual data, linguistic data, cultural heritage data, and so on. Textual data includes literary works, historical documents, and transcripts. Visual data covers images, paintings, sculptures, or architectural designs. Linguistic data relate to languages, phonetics, and syntax. Cultural heritage data are the records of historical artifacts, traditions, and art forms. This type of data may be observed in humanities. Other than these, data may be categorized as dealt in many other fields. In educational sectors, academic performance data, enrollment data, behavioral data, curriculum data, Or in case of medicine or healthcare, we can observe clinical data, genomic data. Clinical data are collected from patients during treatments. Genomic data are information about DNA and genetic makeup. Epidemiological data relate to disease patterns and health outcomes in populations. Again, in the industrial sectors, data refers to the various, and again in industrial sector, industry data refers to data collected within various sectors like manufacturing, finance, retail and other business areas. These data are used to improve operations, track performance and guide strategic decisions. Manufacturing data is generated from production process, tracking the efficiency and performance of manufacturing systems. Financial data are related to monetary transactions, company finances and economic indicators, etc. And retail data are collected from retail operations focusing on customer behavior, sales and inventory and used to optimize marketing strategies, inventory management, customer experience, sale forecasting, etc. In case of e-commerce, data pertains to collected data through online platforms, focusing on customer interactions, transactions and product related information. In e-commerce, we can observe customer data, transaction data, product data, etc. Again, in case of e-governance, data pertains to those set of data which are generated or used by governments to manage public services, administrations and to build policies, such as public service data. These are related to provisions of government services and programs for the public, such as healthcare, education, transportation, public infrastructure, energy consumption, etc. Again, in e-governance, there are citizen data which are collected about citizens for administrative, legal and social purposes such as voter registration, tax records, social security information. These are used for public policy making, resource allocation, demographic analysis and governance improvement. Another type of government data are regulatory data, which relates to laws, policies, regulations that govern sectors like finance, healthcare and the environment. Thus, data not only in research and development, data may be categorized in according to the fields or disciplines where those data are used for their research and developmental activities. Again, in our practice sectors like industry, e-commerce, e-governance or any sector like education or educational administration, healthcare, everywhere we can experience generating and utilizing data by the stakeholders. Now, we move on to the sources of data. The data are generated and utilized by different disciplines in their research and developmental activities or in different sectors for their practices are to be collected from authentic sources. So, what are the variety of places or platforms or methods from where data may be collected for better decision making, for better R&D activities, etc. So, data can be sourced from various places, platforms and methods, both traditional and modern. Understanding the different sources of data thus are crucial to determine how to collect, manage, process and use it effectively. The source of data often influences its quality, accuracy and relevance, and different categories of data depending upon their sources may be categorized as primary data, secondary data and external data, internal data and so on. Now we discuss on these different types of sources and the type of data depending upon these type of sources. Now primary data. Primary data refers to data that is collected first hand by the researcher or organization for a specific purpose or project. It is considered the most direct and original form of data. These are collected by investigator directly from the field of inquiry for some specific purpose or to solve some specific problems. Primary data are thus newborn and original data collected specifically for a particular study or research. It is often more accurate because of the data collection process is controlled. Primary data, collecting primary data can be time consuming, expensive and resource intensive to gather. These are highly specific to research questions and can be subject to biases depending on how these are collected. The methods of collecting primary data may include different methods like survey, interview, observation, experiment, field work, etc. And these methods again use different data collection tools such as questionnaire, schedules, etc. And what is secondary data? Secondary data are collected by certain people or agency but used by others for some specific purposes. These types of data are usually collected by government or non-government agencies in a routine manner and used by other according to their requirements. Sets of figures given in yearbooks, census reports, official publications and records are examples of secondary data. There are two main drawbacks of secondary data. These are firstly the appropriate type of secondary data as needed by the investigator may not be available, and secondly the authenticity of the data on which the secondary data is based must be verified properly. Even when relevant secondary data are available, their scope, coverage and definitions may not tally with the investigator's view. Apart from this, major classification of data may be characterized in other ways too, such as internal data and external data. Internal data refers to the data that is generated and collected by an organization or business from its own operations. This data is typically stored in internal databases and systems and it is proprietary to the organization. The examples of such internal data may be customer data, sales data, employee data, operational data, etc. External data are those which are collected from outside of an organization, typically from third-party providers or publicly available sources. This data is external to the operations of the organization but can provide valuable insights and context. Examples are public data sets, commercial data providers, social media, web scraping, Internet of Things, etc. Now we discuss briefly, now we introduce big data. Big data refers to extremely large data sets, often so vast that traditional methods of data processing and analysis are inadequate. Big data often involves large scale data sets that are collected and generated in real time, requiring specialized technologies and methodologies to process. The main characteristics of big data are its volume, the velocity, the variety and the veracity. And the sources of big data are maybe social media, Internet of Things, web logs, sensor data, etc. Through social media, vast amounts of data are generated through user interactions, posts, likes and shares. By using Internet of Things, data may be generated from billions of interconnected devices such as smart home system, wearable technologies and industrial sensors. From weblogs or from web activity, data may be collected such as clicks, visits and user behavior across different websites. Through sensors, big data may be generated from physical sensors that monitor environment conditions, machinery performance or health metrics. And these are the sources of big data. Now, what is open data? Open data refers to data sets that are freely available for anyone to access, use and share. Open data is typically provided by governments, research organizations and other entities as part of open data initiative, and thus it is also a major source of data. These are publicly accessible without restrictions on usage or distribution. These promote transparency and collaboration across industries and sectors. And some examples of open data are government databases, research publications, international organizations and their public data. Now from government databases like from local, regional or national levels of governments, data may be obtained about demographics, healthcare, public health, crime rates and more. From research publications, data made available for academic institutions and research organizations to advance knowledge and promote innovation. International organization, data shared by entities like the World Bank, WHO or United Nations on global issues like poverty, climate change and economic development are also examples of open data. Now, in this class, we have studied the significance of data in research and development, their different types and sources. Core data plays a very crucial role in dealing with data in different fields of science and in other areas of knowledge which works to create new knowledge. We have also covered it in brief. We have focused here, although we have focused mainly on different categories of data and its various sources. Different types of data dealt in sciences, social sciences, humanities, industrial sectors, government policy making and in other areas of study and practice have also been studied. We have also discussed different sources of data like primary data, secondary data, external data, internal data, sources of big data and open data. These may vary widely in terms of accessibility, quality and purposes. By understanding different categories of data and its various sources that provides the scope of availability and accessibility of data to the stakeholders in different fields of study and practices, individuals as researchers, decision makers, policy makers and also organizations can unlock the potential of data, transforming it to required information and finally into actionable knowledge. A strong foundation of this understanding not only ensures data quality and usability but also prepares individuals to tackle more advanced challenges in data handling and management and making informed decision in a world increasingly driven by data. That is all for this class. Thank you.